Dear students, today we are going to discuss about set, the fundamental concept of set theory. Set is the term which already you are familiar. Literally, you used to apply the term set of pen, set of utensils, pen set, tea set, dinner set. So literally, you have been using this term, but in mathematics it is little bit different. So it's actually a collection, no doubt, but the collection of some objects which are called elements or members of the set. Important point is the objects must be well defined. If we are not able to define the objects, then it will not be possible to collect the elements, the members. So it's simply collection of well-defined objects, and obviously no order is maintained. So unordered it is always. And for example, if we say the collection of vowels in English alphabet, then it is well defined because we know what the vowels are in English alphabet. Then we see in this set, that is set of vowels, then we will have some members or elements, and these are A, E, I, O, U, and it is expressed within second bracket using comma in between elements. So comma is used to distinguish the elements, which is mandatory, and second bracket is strictly used to express a set. So first 7 prime numbers, another collection. If we observe the first 7 prime numbers, then we have the numbers 2, 5, 2, 3, 5, 7, 11, 13, 17. So these are the prime numbers, which are first 7 prime numbers. So this is a collection, and we do not have any problem to pick up the elements because the objects are well defined. It is nicely defined that first 7 prime numbers. So it is well defined, and that is why we can collect very comfortably the elements. Now, how sets are represented? How we represent sets? There are basically two methods to express a set. First, listing the members of a set, listing, or we can say tabular form, or we can say roster form. So author-wise terms are different, so all are same. Listing the members, tabular form or roster form. This is the first way of representing a set. As second is definition by property, or we can say set builder form, set builder notation or set builder form. Basically, using these two methods, two ways, we can represent a set. For example, if we observe some elements, some integers between 50 and 63, even integers between 50 and 63, then if we use the first method, that is listing the members or roster or tabular form, then simply we write the members within second bracket using comma. Even integers between 50 and 63, we simply write the even integers which are lying between 50 and 63. So this is by the first method, that is listing way. And second is set builder form. In set builder notation, if we express the same set, then we need to write in this way, that is within second bracket, which is compulsory, x such that x less than 63 and x is greater than or equal to 50. What is x? The x is an even integers. So this condition indicates all the numbers between 50 and 63, but the numbers are even integers. So this is the way how we need to write a set, and in this way when we represent a set, it is called set builder form. First x indicates all the elements. This x represents all the elements of the set. Now what about x? We have to mention after such that. So here about x we have to write its properties. What is x? We have to write here. Any number of conditions we can add here. Here are two conditions. One is x less than 63 greater than or equal 50. Another is x is even integers. So another condition, if is necessary, we can put here. So that means this x indicates all the elements, and about these elements properties we have to write here, so that we can get exactly the numbers which are a number of elements elements of the set according to defined in the question. So even integers between 50 and 63, this collection, this set we can represent in two ways. First one, it is tabular form or roster form, or just listing the members. Second one is set builder form. So when a set is represented in this structure, then we call it is set builder form. Some important sets basically used in discrete mathematics. So natural numbers, it is denoted by capital N. It is wrongly typed here. 0 should not be here, because 0 is in set of whole numbers, and in set of natural numbers we have just from 1 to 3, etc. Integers, set of integers, it is denoted by capital Z. This all integers, collection of all integers. And Z plus, it indicates the collection of all positive integers, 1, 2, 3, 4, so on. Rational numbers, it is denoted by capital Q. The set of rational numbers denoted by capital Q, and you know the set of rational number is defined in this way: P by Q. Q is integer, P is integer, and denominator should not be equal to 0, and capital R represents always set of real numbers. Next you see equality of sets. That means when we can say two sets are equal. So two sets are said to be equal if and only if they have same elements. Here you see 1, 2, 3, and here 3, 2, 1, and here 1, 2, 1, 3, 2, So in these three collections, if we observe, basically in these collections, in each of these collections, basically three elements are there, that is 1, 2 and 3. So the sets are equal. In this example, if you observe 1, 2, 3, 4, 4 elements are here. 1, 2, 2, 4, 4 elements are here. Number of elements same, but here 3 element is present and here 3 element is absent. That means all elements are not equal with other sets. That is, elements are not equal. Number of elements same, 4 elements, here also 4 elements, but elements are not same. That's why we cannot say these two collections of elements, that is two sets, are not equal. Next you see subset. So what is subset? In this figure, if you observe, this is a set represented by capital B, and this is another set which is represented by capital A. If you observe here, then we'll find that all the elements of set A are contained in the set B. That means all the elements of A are exactly inside the set of B. So when all the elements of a set are purely contained in another set, then we call first set is the subset of the second set. So that means here A is the subset of B. It is symbolically denoted as this one. A is the subset of B. When that means all elements of A are contained in B, and it is mathematically denoted by this symbol and read as A is the subset of B. Next you see, if the number of elements of a set is infinite, then we call it is infinite set. Set of natural numbers is an infinite set. We used to write this capital N within second bracket 1, 2, 3, so on. So this is set of natural number which is infinite set. Set of real numbers is infinite set. Set of rational number is infinite set. Set of integers is an infinite set. So all these are infinite set. Simply in terms of the number of elements in a set, it is termed as infinite set. So next, power set. What is power set? When a non-empty set is given, suppose S is any set is given, and if we write all the subsets of S, all possible subsets of S, then with these subsets, if we form a new set, that set will be power set, and power set is denoted by P of the set. Here S, so it is P of S. If it is A considered, then it would be P of A. So power set means, power set of a particular set A means collection of all subsets of the given set. So empty set means, actually by the term we can understand, empty set means when a set has no element, then it is called a set with no element. So it is called empty set, or sometimes said it is null set, sometimes said it is void set. So null set or empty set or void set, it is always denoted by phi. It is always denoted by phi. And since phi has no elements, that is empty set has no elements, so empty set is always considered as the subset of any set. Empty set phi is considered always as a subset of any set. Very important point it is. Let's consider an example. Suppose this is a set of having two elements 1 and 2. This set comprises two elements 1 and 2. Now what will be the power set of this? First of all possible subsets we have to write. So with these two elements, how many sets can be formed? Taking only one element, we can have one set. Taking only two, we can have another set, subset it would be. And taking both the elements, we can have another set. And phi is always considered as the subset of any set, so phi is also coming here. So thus 1, 2, 3, 4. These four subsets are here, or we can have four subsets from this set. So this collection of all subsets is definitely power set of this set. So P of this means power set of this set. Power set of this set is this one, collection of all subsets. So this set is a subset of this. This is also subset of this. This is subset of itself, and phi is always considered as the subset of any set. So this is the collection of all subsets of the set, this one. So power set of this will be this one. And number of elements will be 1, 2, 3, 4. So this indicates the number of elements of the power set, and which is 4. 1, 2, 3, 4. That means 4 elements are here. Similarly, if we consider another set having 3 elements, 1, 2, 3, then all possible subsets we can form like this. So there will be 8 number of elements. Taking 1, it is only taking one set. Only 2 considering, we can have another set. Only 3 considering, we can have another set. Taking 2 at a time, we can have these 3. Taking all elements at a time, we can have another set. So all this phi is always subset of any set. So all possible collection of subsets from this set is written in this way. So power set of this will be this one, which has 8 number of elements.